Hi everyone, in this video we'll be looking at examples of solving simultaneous equations using a few different methods. The examples I'll be going through are available in the link to the description in case you want to give them a go yourself, and there's also some timings there for different parts of the video, so you'll be able to stick to a certain question. Now the idea of this video is that you'll be able to see how to approach different types of problems, as well as learn some tips and tricks that might help you along the way. So as I go through the questions, I'll assume that you have some prior knowledge about simultaneous equations, but if not, then first watch the recommended video in the description so that you can nail the theory before watching this video. So let's start the examples. Now as I go through these, I'll start by talking through exactly what I'm doing in detail, but as I go on I will speed up as you'll have an understanding of the basics. So we are first going to look at examples where we solve problems using the elimination method. And the first question is asking us to solve the following simultaneous equations. And we have a list of different sets of equations underneath. Now the first set of equations are 5x plus 3y is equal to 41 and 2x plus 3y is equal to 20. Now the first thing to notice about these two equations is that the y coefficient is the same, which means we can eliminate y quite easily. If I just to rewrite the equations, so we have 5x plus 3y is equal to 41 and 2x plus 3y is equal to 20, then what we can do is we can subtract the second equation from the first one, so that we have 5x minus 2x, which is 3x, 3y minus 3y, which is 0, and 41 minus 20, which is 21. So then this means that x is equal to 21 over 3, which is equal to 7, which means we already have our solution for x. And we can do something similar to find y, but we do need the x variables to have the same coefficient. So in this case, what we want to do is we want to times or divide each equation by a factor in order to get the coefficients of x to be the same. So if we have 5x plus 3y which is equal to 41, and we have 2x plus 3y is equal to 20, then the lowest common multiple of 5 and 2, which are the two x coefficients, is 10. So if I were to times both equations by a factor to make the coefficient of the x variables equals 10, then I'd be able to eliminate x, which would give us the value for y. So we want to times the first equation by 2. So times that by 2, which would give us 10x plus 6y is equal to 81. And then we want to times the second equation by 5. So times by 5, which would give us 10x plus 15y, which is equal to 100. And now we can subtract the second equation from the first equation. I'll just change pen colour to get 10x minus 10x, which is 0, 6y minus 15y, which is negative 9y, is equal to 81 minus 100, which is minus 18. And then this implies that y is equal to minus 18 over minus 9, which is equal to 2. So then the solution for our set of equations is x is equal to 7 and y is equal to 2. But let's double check this just to make sure none of our calculations are incorrect. So if we have 5 times 7, which is our x value, plus 3 times 2, which is our y value, we'll get 5 times 7, which is 35, plus 3 times 6, which is 6, and 35 plus 6 is equal to 41. So we know that our solution works for the first equation. And then for the second equation, we will have 2 times 7 plus 3 times 2 is equal to, well, 2 times 7 is 14, and 3 times 2 is 6, so 14 plus 6 is equal to 20, which means that the solution also works for the second equation. So that means at this point, we simply write x is equal to 7 and y is equal to 2, which is our final answer. So I have another example here where we can do the same things, but in this case we have 5x plus y is equal to 11 and 3x minus y is equal to 9. So we'll do the same thing again. We can see straight away that But the coefficients of y are 1 and -1, which means that we can add the equations together to eliminate y. So if we were just to rewrite the equations, we've got 5x plus y is equal to 11, and 3x minus y is equal to 9. So in this case, we want to add the equations together to eliminate y. So 5x plus 3x is equal to 8x. Positive y plus negative y is equal to 0. And 11 plus 9 is equal to 20. So this implies that x is equal to 20 over 8, which is equal to 5 over 2. And then we'll do the same to find y. So if we have 5x plus y is equal to 11, and 3x minus y is equal to 9, then we want the coefficients of x to be the same. So the lowest common multiple of 5 and 3 is 15. So we'll times the first equation by 3 in order to get 15x plus 3y is equal to 33. And then we'll multiply the second equation by 5, so that we get 15x minus 5y is equal to 45. And now we're able to subtract the second equation from the first equation to eliminate x, which will just leave us with y. So we would have 15 minus 15 is equal to 0. 3y minus 5y is 3y plus 5y, which is 8y, is equal to 33 minus 45, which is minus 12. And then this implies that y is equal to minus 12 over 8, which is equal to minus 3 over 2. And then we want to check our solutions correct just by substituting it back into the equations. So we'll have 5 times our x value, which is 5 divided by 2, plus our y value, which is minus 3 over 2, is equal to, or 5 times 5 over 2 is 25 over 2. So 25 over 2. And we want a minus 3 over 2. So minus 3 over 2. And since the denominators are the same, we can just subtract. So 25 minus 3 is 22 over 2, which is equal to 11. So we know the first equation is correct. And then for the second equation, we have 3 times 5 over 2 minus y, which is minus 3 over 2, is equal to, well, if we have 3 times 5 is 15, so that's 15 over 2, and 15 over 2 minus 3 over 2 is plus 3 over 2. And since the denominators are the same, we can just simply add the numerators together. So we have 18 over 2, which is equal to 9. So the solutions for the second equation is also correct. And then we simply want to put our final answer, which is that x is equal to 5 over 2 and y is equal to minus 3 over 2. So that's a solution that satisfies both equations. Now I have a third example here, but I want you to have a go at this yourself. There is solutions in the link in the description. It's exactly like the two that we've just done, so you should be able to just follow the steps that I did in the first two and you'll be able to get the correct answer. So now we're going to move on to substitution. So this is a different method that you can use to solve simultaneous equations. This method I do prefer over the elimination method, but with this method it can be easier to make a mistake because it involves rearranging. But yeah, so we have 4x minus 4y, which is equal to 24, and we have x minus 4y, which is equal to 3. So when we're doing substitution, what we're wanting to do is we're wanting to rearrange one of the equations, so preferably the easiest one to rearrange, for one of the variables. So we have it in the form of x is equal to some stuff or y is equal to some stuff. So straight away I'm going to choose the second equation. I'm going to choose that one because there isn't a coefficient on the x. So we can simply just have x is equal to 3 plus 4y. And then what we want to do is substitute that equation for x into the other equation we didn't choose earlier. So what I mean is that we want to have 4 times 3 plus 4y. So we've substituted what would be the value for x minus 4y is equal to 24. So what we've just done there is we've just got everything in terms of y's and numbers, so that when we simplify this and rearrange, we're going to get y is equal to some number, and then that value is going to be our solution for y. So if we expand this bracket here, we have 4 times 3, which is 12, and we have 4 times 4y, which is plus 16y. Minus 4y is equal to 24, and then we want to rearrange for y, so we have 12y is equal to 12, which means y is equal to 1, which is our solution for y. So now if we substitute our solution for y into our equation for x, which is this one here, we would get x is equal to 3 plus 4 times 1, which means x is equal to 3 plus 4, which means x is equal to 7. We're then able to check our solution by substituting it into both equations. So for the first equation we have 4 times our x value, which is 7, minus 4 times our y value, which is 1, is equal to, well, 4 times 7 is 28, and 4 times 1 is 4, so we have 28 minus 4, which is 24, so we know our solution works for the first equation. And then for the second equation, we have x, which is 7, minus 4y, which is 1, is equal to, so we have 4 times 1, which is 4, which means we have 7 minus 4, which is equal to 3. So our solution also works for the second equation. So just as the last line of our workings out, we want to state that x is equal to 7 and y is equal to 1. So we'll do another example of substitution here. So this time both x and y values on both equations have coefficients. So this is where the rearranging gets a little bit more messy, but we just have to be careful. So we'll choose our first equation to rearrange for x, but we could choose y instead if we wanted to. So I'll choose the first one, there's no reason why. So we're going to have 2x is equal to 14 minus 4y. Which would give us x is equal to 14 minus 4y divided by 2. And then since 14 and 4 can be both divisible by 2, this would leave us with 7 minus 2y. Now if we substitute our equation for x into the other equation, we're going to get 4 times 7 minus 2y minus 4y is equal to 4. And then we can expand this bracket, so we have 4 times 7, which is 28, and 4 times minus 2y, which is minus 8y. Minus 4y is equal to 4. And then if we simplify this and do it in terms of y, I'm going to move the y's to the other side so that we have 24 is equal to 12y. And then this implies that y is equal to 24 over 12, which is equal to 2. And then we can substitute our y value into the equation for x, so that x is equal to 7 minus 2 times 2, which equals 7 minus 4, which is equal to 3. So this means we have x is equal to 3 and y is equal to 2. So if we just check our answer by substituting those values into the two equations, we're going to get 2 times our x value, which is 3, plus 4 times our y value, which is 2, and that's going to equal 2 times 3, which is 6, plus 4 times 2, which is 8, and 6 plus 8 equals 14. So the solutions work for the first equation. And then for the second equation, we have 4 times 3 minus 4 times 2, which is equal to, so we have 4 times 3, which is 12, minus 4 times 2, which is 8, and then 12 minus 8 equals 4. So the solutions work for the second equation. So we want to write a final answer that says x is equal to 3 and y is equal to 2. And again, I have an example here that you guys can do yourself. It's just the same as the two questions before, so you should be able to use those workings to help you.